Good morning, everyone. Hope all is well. Everyone's all right. Giving everybody a few seconds to get in and then we'll get started.
You're still alive, right?
I'm alive. I'm talking about this.
I'm scrolling through this.
All right. Good morning, everyone. Hope everybody's doing all right. Everybody's doing okay. So last class, we were in 6.3. We did some word problems. If you missed that lecture, I'll be shooting that out to you, hopefully by the end of the day, if not, most definitely by tomorrow. So this is the last part of 6.3, and we're talking about solving for specified variables. All right. So in this section, they'll give you a formula, like you see right here, it says solve the formula for a certain variable. And let me do this. And take this back some. So we have P equal to 2L plus 2W. And we want to solve for L. So whenever you solve for a specified variable, there's no guarantee you're going to have something like L equal to 2. In other words, having a solid number. You're more than likely going to have more than one variable. And you're going to have your one variable that you're solving for on one side of the equation, and you're going to be equal to an expression. So here we have three different variables, but what is key here is that we have to remember that each one of these variables represent a number. So we treat them like we would numbers. So over here, I was just presenting the scenario. If I had 7 equal to 2L plus 5, how would I go about solving for L? The first thing I would do is subtract 5 from both sides. So that same thought process should be taken here. I have P equal to 2L plus 2W. My goal is to get L alone on one side of the equation. So I subtract 2W from both sides. 2W minus 2W will cancel. And that'll leave me with P minus 2W equal to 2L. Now the P minus 2W, they're not like terms, so you cannot combine them on that left side. So that's what we have at this point. Still need to move the 2 off of the L. But before we do that, any questions so far? Make sure we're okay. All right. So go ahead and divide both sides by 2. And that'll give us our answer, L equal to P minus 2W over 2. So before you go any further, we're going to talk about the incorrect way and the correct way if we wanted to simplify more. But notice I put in this green circle right here. This is good enough because notice this 2 cannot divide evenly into each term. So, and I'll show you what I mean by that in a second. But that 2, if there was a, let's say 10 in front of P, then the 2 could divide into both of those numbers of 10 into the 2, but it cannot. So leaving it like this is good enough for your answer. So a lot of people though, they'll see that 2 in the numerator and 2 in the denominator and they want to cancel them. So I just want to make sure we see what you can and cannot do if you decide to go further past this expression. So here, notice it says incorrect in orange. What you cannot do is cancel out those 2's and have P minus W. This is incorrect. Now, if you wanted to go further, where you at? Say go. All right. Talking right here? Yep. All right. So for those in the Zoom, we have a question in the class asking us what made us do these moves right here. So the fact your goal is to get this L by itself. So you need to remove everything that's on that side of the equation to the other side. The only way you can do it is by performing the opposite operations. So when I look at 2L plus 2W, that's 2 times L plus 2W. So I need to undo the addition of 2L and undo the multiplication of the 2. I mean, not 2L, but undo the addition of 2W and undo the multiplication of 2. So to undo the addition of 2W, I have to subtract 2W. And so that's why I subtracted 2W from both sides. And then to undo the multiplication of 2, I divide by 2. So whatever you do to one side of the equation, you have to do to the other side in order to keep your equivalence. And so in your equation is separated by the equal sign. So whatever you do to the right side of the equal sign, you have to do to the left side. So what you're presented initially is what prompts you to move in what direction you will move. Yep. No, it's incorrect because 2, as if you're trying to simplify further, the 2 has to go into each term in the numerator. You can't just take it into one term. See how if I just do it like that, this says the 2 affects this term, but I didn't take it into the P. Yeah, so everything, so for those in the Zoom, your classmate was asking, well, what's the difference between this and then this here? And the main thing is that here, you're only dividing 2 into the 2W, but to simplify properly, this 2 has to divide into both terms in your numerator. Okay? And so that's what makes it correct. So notice here, we have P over 2 and 2W over 2. The 2 can now cancel, which is what we want to do, but we still have P over 2, and that can't go anywhere. So that is the correct answer. So this and this represent the same expression. So either one of those answers are fine. And that's why I put over here, this wasn't necessary, but I know some people may want to go further. I just want to, what I wanted to make sure was that people didn't do this over here. That was the main thing of going through that. So any questions on that? Anybody in the Zoom, everybody okay with what we're doing? Make sure we're all right. Anybody still copying? Can I scroll up? Oh, somebody said something in the chat. Okay, cool. All right, so here I just wanted to show you a scenario in which you can move further and they do expect it. So if you had a 4 in front of P, so in other words, 2 can divide into that 4 and 2 can divide into this 2. So if that is the case, then you must reduce. They are expecting you to do so. They will expect you to take the 2 into each term because it can be done. And this 2P minus W will be the most simplified way of expressing that expression. Everybody all right? Any questions on what we did here? Got at least one more. Everybody good? Go to the next one. Okay, so next one we have T equal to D plus PM, and we want to solve for P. So one thing I want to make sure we're okay with as well when it comes to whether it be math lab or any problem, any assignment, always hold true to your capital letters and lowercase letters. So if you have capital T and capital D, lowercase p, lowercase m, you are expected to hold true to that. So if you were to go into math lab and use a capital P, they will mark it wrong. Because in mathematics, lowercase p and capital P represent 2 different numbers. So you do have to hold true to any capital letters that they give you and any lowercase letters that they give you. So once again, we have capital T and capital D, lowercase p and lowercase m. Our goal is to set P, solve for P, so we want to set P by itself. First move is to subtract D from both sides. So these will cancel, leaving me with T minus D equal to P times M. And then divide both sides by M, T minus D over M, and that's equal to P. Any questions, any questions? Is everybody good? Go to the next thing. Everybody still copying? All right. So that's it for chapter 6. That's 6.1, 6.2, 6.3. We've talked about. We're going to get into 7.1. We're not going to finish it, just get in there because we have time. And 7.1 actually takes us into graphing. Looking at our Cartesian coordinate plane. So our Cartesian coordinate plane is made up of two axes. We have our x-axis, which is our horizontal axis, y-axis, which is our vertical axis. They intersect at the origin. Coordinates of our origin is 0, 0. Everything to the right of our origin is positive. Everything to the left of the origin is negative. Above the origin is positive. Below the origin is negative. It's also split up into 4 quadrants, going counterclockwise. Quadrant 1, quadrant 2, quadrant 3, and quadrant 4. To get into quadrant 1, you have to make 2 positive moves. Into quadrant 2, negative, then positive. Quadrant 3, 2 negative moves. Quadrant 4, positive, then negative. We'll be graphing by what we call ordered pairs. They're called ordered because the order matters. So it's always X first, then Y. So that means your horizontal move first, then your vertical move. Or, you know, in whatever way, you know, it helps you out to remember. You want to think about walk to the elevator and go down, maybe run and then jump, or, you know, X comes before Y in the alphabet. But always remember your horizontal move is first and then your vertical move. All right. Let's see people writing, something in the chats. All right, you guys still copy? Open up. All right, so let's graph a few points. All right, so we have these 6 points right here. Just want to make sure we're okay with how we're gonna graph, and you know what points would go where and all the good stuff like that. So we have 2, 5, +2 and +5, and we're gonna graph the ordered pair. always start at your origin. So if I start at my origin and I'm going +2, +5, it means I'm going to the right 2, up 5. So that will put my point right here. All right, and that is quadrant 1. So it's 2 positive moves, -1, -3, 2 negative moves. I will start at my origin, go down 1. I mean, not down 1, left 1, down 3. So that will put me right here in quadrant 3. Next one, left 4, up 2. Puts me right here, which is quadrant 2. And then the fourth one, to the right 1, down 5. Puts me right here in quadrant 4. Questions, any questions? All right. So last two, just want to be careful here. Somebody unmuted.
Yes, the positive 0 and 3,
Mhm.
shouldn't it be on the y-axis? The 0,
Mhm.
0,
Yep.
3.
Yep. So like she said, you would go to the right 3, but then nowhere for y. So that will put you on the x-axis.
No, I'm talking about the next one.
Yeah. Yeah, you're right. And so,
Okay. Because it's placed all the way over there. That's why I was kind of confused.
yeah, I was gonna draw my arrow.
Oh,
Yeah.
okay.
Because see the way I had it before, I had something else right here, and so I moved it down and stuff. So yeah, I was just gonna draw an arrow to it. Yeah.
Okay, thanks. Just making sure.
Oh, you on it? You good? You good? So, like she was mentioning, you don't move anywhere for this last one right here, 0, 3. You don't move anywhere for x, but you go up 3, and so that's going to be on your y-axis. And so I was just going to do that. Yeah. All right. Questions before we go any further? Make sure we're okay. All right. Can I scroll up? Anybody copying Zoom? All good. Okay. All right. So the next thing, solutions. So we talked about solutions before when we just talked about one variable, but here we have 2 variables where we have ordered pairs. So an ordered pair is a solution of an equation if the equation is true after the ordered pair is plugged in. All right. So for this example, we have 4x minus 3y equal to -2. And we have the ordered pair of 1, 2. So don't forget when it comes to your order pairs, X is always first and then Y. So you plug them in accordingly. X going in, 1 going in for X, 2 going in for Y. That's what we did right here. 4 times 1 minus 3 times 2 equal to -2. 4 times 1 is 4, 3 times 2 is 6. So that's 4 minus 6. And that leaves us with -2 equal to -2, which is true. And so that will be an ordered pair. That will be a solution of this equation. And so that ordered pair would also be a point on the line that this equation generates. So that's why I was stating right here, every solution is a point on the line. So when you go about graphing, we're going to get into that in a second. When I graph a line, all of those points that represent that line are solutions for that equation. And so there are infinitely many solutions to a linear equation. You'll see copy. All right, can I scroll up? All right, so let's try it one more time. Let's make sure we're clear on substitution and what a solution looks like and what it doesn't look like. So here we have the equation, y equal to 3x minus 5. And we have 2 ordered pairs that we want to try, 2 separate points. So 1 point or point 1 is 2, 3. The second point is 3, 4. So make sure you plug them in accordingly. The first 1, 2, 3 is going to be 3 for y, 2 for x. That substitution is happening right here. So it's 3 equal to 3 times 2 minus 6, 3 times, minus 5, excuse me, 3 times 2 is 6. 6 minus 5 is 1. So you see we have a statement of 3 equal to 1. So that's telling us that that's not a solution. And then for the next one, we have 3, 4. So plugging in 4 for y, 3 for x, 3 times 3 is 9, 9 minus 5 is 4. So that is a solution because we have 4 equal to 4. Any questions? Any questions? Scroll up. Very good. All right. So let's go ahead and get into graphing these equations. So we're going to be graphing linear equations for the most part when it comes to our graphing. So the first method, we have three different methods. The first method is using the XY chart, generating an XY chart. We'll talk about that in this section right here, 7.1. Second, graphing by using your intercepts. We'll talk about that in 7.2, and then graphing using your slopes. We'll talk about that in 7.2 as well. Also, I didn't mention, since it says graphing linear equations, key word in linear, and the word linear is line. So for the most part, the graphs that you will be graphing will be straight lines. There will be one scenario where it will be a little different, and I'll show you in a second. Method will be the same, but the outcome will be different. All right, so let's look at this first method, generating the XY chart. All right, so we have the equation of y equal to 2x plus 1. So create a chart and choose whatever x values you want to plug in. I'll show you why it doesn't matter in a second, but you get to choose whatever x values you want. Just remember that whatever you choose, you have to plug it in, you have to calculate, and you have to graph. So if you choose 150 and 1 million, just remember you have to graph that. So notice I just chose some simple values, -1, 0, and 1. If you don't want to use any negatives, you can do 1, 2, and 3, and it doesn't matter. Like I said, I'll show you why it doesn't matter in a second. Also in MATLAB, they're only going to need 2 values. I'm just used to doing 3 just because of how I was trained and how we did it back in the day. But MATLAB only needs 2 values and only needs 2 ordered pairs. All right. So you choose x values, then you need to find a corresponding y value. So you're going to take -1 and plug it into the equation. This equation right here for x. So that's 2 times -1 plus 1. 2 times -1 is -2. -2 plus 1 is -1. So it just so happens that when x is -1, y is -1. Do the same thing for 0. 2 times 0 is 0, plus 1 will give me 1. And then for the last one, 2 times 1 plus 1. So 2 times 1 plus 2 times 1 is 2. 2 plus 1 is 3. So we have our 3 ordered pairs. Any questions before we go to our graph? So here are our 3 ordered pairs now, and you need to graph all 3 ordered pairs. Well, in MATLAB, you're only graphing 2 of them, and that will give us our line. So we go -1, -1. So I'll go to the left one, down 1. That's this point right here. Nowhere for x, up 1. That's this point right here. And then to finish it off, to the right one, up 3, is this point right here. And connect the dots, and you'll have your line. All right. So just to remind you, remember I mentioned how it doesn't matter what points you choose. Notice we have arrows going in each direction, up and down. And so it means it just goes into infinity in those directions. So that means if I would have chose X to be 20, 20 would have been over here somewhere, but it would have gave me a point for Y that would connect it to this line and gave me the same line. Same thing if I would have chose negative 100, it would have been a point that was way over there to the left, but it would have gave me something down here that still would connect it and made the same line. So either way, you'll still get the same line. It's just that, like I said, whatever you choose, you're gonna have to calculate and you're gonna have to graph. So that's why you always wanna make sure you choose some easy values and values that are close to each other. All right, so let's do one more like this. Here you're gonna have to be a little strategic in what you choose. I'll just leave it up and just talk it out. So we have Y equal to negative 3/5 X plus 2. So you don't want to have to graph. You see, we have a fraction, but you don't want to have to graph fractions or graph decimals if you can get around doing so. And you can, as long as you are strategic in what you choose. And so if you look at your denominator, in this case, we have 5. If you choose X to be multiples of your denominator, or in other words, numbers that your denominator can divide into evenly, then you will be ensured that you won't have any fractions or decimals. So notice I chose -5, 0, and 5 because those are numbers that 5 can divide into, and I was holding true to my -1, 0, and 1. But you could have chose 5, 10, 15, 20, -5, -10, -20. Anything that 5 can divide into are values that you can choose that will be okay for you to calculate and then graph. So choosing -5 is this calculation right here. I did -3/5 times -5 plus 2. Now, if you wanted to cancel first and then multiply, you could. You could have canceled out your 5s and everything. But here's just a way to just map it out so everybody can see what's going on. So the -3/5 times your -5, you just multiply across, and that'll give you positive 15 over positive 5 plus 2. 15 divided by 5 is 3. And then 3 plus 2 is your positive 5. All right. So when X is -5, Y is positive 5. Next one, plug it in 0. 0 is always a good one to use because 0 will cancel out the fraction completely. So 3/5 times 0 is just 0. 0 plus 2 is 2. And then last one, plugging in positive 5. So 3/5 times 5 will give you -15 over 5. -15 over 5 is -3, and -3 plus 2 is -1. So when you plug in positive 5, you get out -1. All right. So before we go to the graph, make sure we're good with our calculations. Yes, sir. Right here. Yes. So any number, if I had 10, it's the same thing as 10 over 1. You can write any number as that number over 1. So I just wrote it that way just so I can have fraction multiplied to a fraction. And just to show that we multiply across. Yes. Okay, so then you go ahead and graph your 3 points. -5, 5. So you go to the left 5, up 5. That's right here. 0, 2. You don't move left or right for X because it's 0, but then you go up 2. And then to the right 5, down 1 is right here. And that will be allowed. Questions? Any questions? Good, everybody straight. All right. So we got one more. Want to graph y equal to 4 minus x squared. All right, so that square on the x stops this expression from being linear. So we're not going to get a straight line in this case. So I chose -2, -1, 0, 1, and 2. Chose a few more values here just so we can get a full picture of what we're going to graph. Once again, Math Lab is going to only going to require 2 points, if I'm not mistaken, with this. And the type of graph that you need, you'll have to pick a button, and you'll see it in a second. I'll show you in a second. But let's just go ahead and calculate with these points. So that's -2, plugging it in. So here, -2 squared is going to be +4. So 4 minus 4 is 0. -1 squared is +1. So it's 4 minus 1, which is 3. 0 squared. 4 minus 0, 0. 4 minus 1 squared is going to be 3. And then 4 minus 2 squared will be 0. All right. Make sure we're okay. It's the same process, even though we're not getting a linear, even though we don't have a linear equation, not getting a line, the process is still the same. You have these values you've chosen for x, going to plug them in to find the corresponding y values for each. All right, so then we can go ahead and graph. And it ends up giving us a parabola, what we call a parabola, basically a U shape. So -2, 0. -2, 0 is right here. -1, 3. 0, 4. +1, 3. And then +2, 0. So it ended up giving us upside down parabola because x squared was negative. If we had 4 plus x squared, then it would have been a right side up. Call it concave up, concave down. This is considered concave down. It would have been concave up if x squared was positive. Questions on anything? Questions? Make sure you do it. All right, well, if you finish up copying, this is where we're going to stop today. This is where my last class got. I'm trying to keep all of my classes in the same spot because I'm making these videos and I'm going to just send out one video to everybody. So this is where we're going to stop here today. That's not the end of 7.1. 7.1, we have function notation that's left in here. And then we'll be done with 7.1. So make sure you guys stay on top of this stuff because we'll be done with 7.1 next class, get into 7.2. So basically next week we'll be done with chapter 7. And then that'll be it for our first block of work. Then I have a test and then I'm gonna try to generate that test this weekend for you guys to go ahead and take a look at as far as first test, which is chapter 6 and chapter 7 content. But other than that, if you guys are good, I'm good. Have a great weekend. Be safe. Well, let me ask this. Anybody have any questions? Yes, sir. Yeah, I'm glad you asked that because what's gonna happen is, first of all, you're gonna have these buttons that you have to click on. So if you're gonna do a linear equation, you gotta click on that button first. And then, but if you're gonna do a parabola, you see a parabola coming up, then you have to do this button. See what I mean? And let me see if y'all have any other ones like x cubed. Okay. So this is x. We do it like this. So for those in the Zoom, I'll explain in a second. Classmate asked a good question. I meant to come back to it. Nope, trying to draw it good. That's good enough. All right, so just in case you guys see it, in MATLAB, if you have just a regular equation that involves x, those are your linear equations. There should be a button that you would click on. You click that button and then use your 2 points. For x squared, which is what we just did, a parabola. Once again, all you need is 2 points, but then you click this button first and then use your 2 points. If you have a cubic one, not sure if you're going to have a cubic one, but there will be a cubic equation button. And then not sure if you're going to have absolute value, but there's an absolute value button as well. That's a V. So absolute value gives you a V. Parabola gives you a U. So, but yep, if you see any of those things and you're not sure, just feel free to ask the question, and I'll most definitely help you guys out on that. Did that answer your question, sir? That makes you okay? Okay. Anything else? Anybody else? Anybody in Zoom? Before we close, make sure we're good. So, you guys be safe. Have a great weekend. Don't forget we're supposed to be getting some snow this weekend, so make sure you be safe on that front. And I'll see y'all next class. All right.
All right, have a good day.
Thanks, you do the same. Thanks, you do the same. Take care. Take care.